The Life and Work of Emmy Noether by Olivia N. Nolan. Emmy Noether was born in Erlangen, Germany on March 23, 1882. She was the daughter of German mathematician Max Noether. As a child, she was not educated in the field of mathematics because it was considered improper for women at the time, and a popular belief held during this period was that higher education would cause irreparable mental damage in women. Instead, she studied language and fine arts, which was expected of upper-middle-class girls at the time. She finished her schooling and was qualified to teach English and French, but chose to audit classes at University of Göttingen and study mathematics. She transferred to University of Erlangen in 1904 because they let women formally enroll, and she received her PhD in math in 1907.
It's important that they did, because otherwise Noether might never have gotten the chance to change physics and mathematics as we know it. Noether discovered Noether's theorem, which states that symmetry implies conservation laws. A symmetry in this context happens when you have some object, apply a transformation to it, like rotating it or translating it, and the object remains the same. Noether discovered that the same meant that the energy was conserved. The second part of her theorem states that if a system does not follow conservation laws, it is not symmetric. Noether's work with symmetries also kickstarted an entire mathematical field, abstract algebra. Abstract algebra is a field of math that covers the structure of mathematical systems, rather than the actual numbers themselves, and many of these systems are related to mathematical symmetries. She also rediscovered the Skolem-Noether theorem, which is too complex to explain here, but is incredibly important to abstract algebra.
Noether's theorem came at one of the most exciting times during the development of physics and math, because Einstein's paper on general relativity had just been published. Two of Noether's colleagues, David Hilbert and Felix Klein, were trying to use the framework of general relativity to write an equation for the conservation of energy, but whenever they did, they would end up with equations that had no real value, like 0 equals 0. So they asked Noether for help, which is when she discovered Noether's theorem. All the excitement in physics during this time period also led to much progress in mathematics, and many mathematicians were thinking more and more about the concepts behind mathematics instead of about the numbers themselves. Noether was also working with these ideas, which is what led to her to create much of the foundation for abstract algebra, and to rediscover the Skolem-Noether theorem. Noether's work is still relevant today, as Noether's theorem is now part of the foundation for the theory of particle physics, and even correctly predicted the existence of the Higgs boson, which was discovered in 2012.
She did all of this work as an assistant lecturer at the University of Göttingen because women were not officially allowed to lecture. At first, she received no salary for her work, but then after 8 years, she finally started to receive a small salary. She taught at Göttingen until 1933, when she was ousted from her teaching position by the Nazi government for being a woman, Jewish, and a pacifist. She then accepted an invitation to lecture at Bryn Mawr College in Pennsylvania, where she worked as a professor for the rest of her life. Emmy Noether passed away April 14, 1935, due to complications from an ovarian cyst surgery. At the time, the importance of her work had not been fully realized, but thankfully is now recognized today. Thank you.